9, inverse function. So if I have a function here, x plus 4, and I have a function here as my inverse is x minus 4, and I have all these ordered pairs, 1, 5, 2, 6, 3, 7, 4, 8, and then my inverse has ordered pairs 5, 1, 6, 2, 7, 3, 8, 4. What happened? What happened? They switched. Okay, an inverse is a switch in x and y. Say it with me. What's an inverse? It's a switch in x and y. It's a very simple concept that we're going to be talking about not only this year, but next year in calculus as well. All right, it's a switch in x and y. So what the domain is of your original function is now going to be the range of the inverse. And what's the range of my original function is actually going to be the domain of my inverse. Because what's an inverse? It's a what? A switch in x and y. True definition of an inverse is, it's when we have a composite. That's why I wanted to go over 39 so much. All right, it's when we have a true composite, we substitute in a function into the variable of the other function, and guess what it pops out? It pops out x. And then if you switch it, you put the other function inside the other function, and it pops out x. They are true inverses of each other. All right, so when that happens, it gets an inverse. Here we go. We're going to find if g of x and h of x are inverses of my function f of x. So what we're going to do is we're going to actually truly make them composites of one another. So the first one I'm going to test is g of x. So I'm going to do f of g of x. And if I pop out x, if x pops out after I do this, what do we know that g and f are? They're inverses of each other. All right? So what we're going to do is we're going to take g and we're going to substitute it in the variable into f. All right? So here we go. So now I end up having 5 over x minus 2 over 5, and then I still have minus 2. This is what's technically called a complex fraction. I like to call them fractions. All right? Technical word for it is a complex fraction. Now, the way we get rid of this complex fraction is we need to multiply by that denominator. All right? So I'm going to multiply by 5 in the denominator. But if I multiply by 5 in the denominator, what do I need to do? Multiply by 5 up top. All right? So when I multiply by 5 over 5, what do I have up top?
25.
25, that's what I'm talking about. And then when I multiply by 5, I end up having x minus 2. Okay, those cancel. And then minus what?
10.
10. Minus 10, because 2 times 5 is 10. So then on the bottom, I now have 25 over the quantity x minus 2. So that's what my composite is. Will that ever give me x? Can I manipulate that function in any way to just give me x? Yeah. X minus 12. Yes. Thanks. Can I manipulate that in any way to give me x? I can't. So is g of x an inverse of f? No. So that is not an inverse. So now we're going to test out h. So we're going to substitute in h into f. So now I need to find f of h of x. So now I still have 5 up top, and then I have 5 over x plus 2 minus 2. All I did was substitute in that function into the variable of the other one. Does anything happen here? 2's cancel. 2's cancel. I love it when that happens. All right, so 2's cancel. And so now I'm left with 5 over 5 divided by x. If I divide by something, that's the same thing as multiplying by its what? Reciprocal. So if I say 5 over x is the same thing as saying 5 times x over 5. And what do I get?
X.
I get x. That's what I'm talking about. All right. So now I have f of h of x. It popped out x. So what do we know about h of x? Yes, it is an inverse of a function. Okay? So when we graph an inverse, again, what's an inverse? It's a what? A switch in x and y. All right? So we did the hard part already. Our function is 2x minus 3, and then our inverse is 1/2 x plus 3. And I want to show you something here. If I substitute in -1, if I substitute in -1 into this equation 2x minus 3, what do I get? I get negative 5, right? So I have negative 1, negative 5. If I substitute in 0, what do I get? Negative 3, right? And then if I substitute in 1, what do I get? Negative 1. And then I substitute in 2, and I end up with 1. And then I substitute in 3, and I end up with 3. All right, so I have that line going just like that. True? However, if I need to graph this inverse, I'm going to say my x values are negative 5, negative 3, negative 1, 1, and 3. So if I substitute a negative 5 into this equation, what do I get? I get negative 1. If I substitute a negative 3, I end up with 0. If I substitute a negative 1, I end up with 1. If I substitute in 1, I end up with 2. If I substitute in 3, I end up with 3. What happened? What? What happened? They switched x and y. And if they switch x and y, those are said to be what of each other? Inverses. Now, I'm going to graph the inverse function of that. Okay? I'm going to graph its inverse. Pretty good? You ready? So, instead of graphing negative 2, 5, what do I want to graph it?
2.
I want to graph it 5, negative 2. So now I go 5 and I go negative 2. And then if I need to graph, what is that, 2, 4? What do I need to graph now? I need to graph 4, 2. And then instead of graphing 3, negative 1, what am I going to graph now? Negative 1, 3. So that would be the graph of its inverse. Okay? Because truly, what is an inverse? It's a switch in x and y. Do you think I'm going to have a graph like this on your test? It's going to happen. All right. Now, this is how you guys were taught inverses last year in Algebra 2. Okay? And this still holds true. I told you there's different ways to tamper. All right? So, first you use the horizontal line test. Number 2, David, read.
Use the in the equation for fx, replace fx function of x by y.
Good. Courtney, 3.
Interchange the roles of x and y and solve for y.
All right, that's what you guys did most of the last year, right? You switch x and y, and then you solve for y. And then the fourth step, people always forget. Angela, what's the fourth step?
Replace y by function f of x in the new equation.
F inverse of x in the new equation. All right, so let's do it. So I need to find the inverse of this function. So my first step is to do what? Replace f of x with y. And then what's my next step? Switch x and y. So now when I switch x and y, I get x is equal to 5 minus 3y over 2. And what do we need to do now? This is where all the good work comes. We need to multiply by 2. We need to solve for y. So we need to multiply by 2. So then we're left with 2x equals 5 minus 3y. And then what? Subtract 5. So now I have 2x minus 5 is equal to negative 3y. Then what? Divide by negative 3. So when I divide by negative 3, I end up getting y equals 2x minus 5 over negative 3. Now, this technically is not wrong. However, it's like bad etiquette. It's rude. All right? It's rude to have this negative 3 on the bottom, so I'm going to distribute the negative up top. All right? So then I end up with y equals negative 2x plus 5 over 3. Okay, I just changed up all my negatives and positives to the other. And then I'm done.
No.
No, I'm not done. What do I need to do? So now I need to say f inverse of x is equal to negative 2x plus 5 over 3. Tyler, what do I do? So what do we get?
Y equals the square root of 2x minus 3.
All right, let's just switch it. Let's just jump. Let's just jump there. All right, now what?
And square root both sides.
Try again. The other one.
Square.
Square. All right. Now what?
Add 3 to both sides.
All right.
Then divide by 2.
All right. So now I get y equals x squared plus 3 all over 2. And I'm done. What do we need to do?
You need to do the inverse of function x.
Good. All right. Everybody got that one? Now, I want to go a step further. To prove a point. I want to know the domain of my original. I want to know the domain of that original. What do we need to do? It's a square root, so what do we need to do? It can't be negative, right? So I said 2x minus 3, what? Greater than or equal to 0. All right? So I add 3, divide by 2, I get x is greater than or equal to 3 halves. So if I write that in interval notation, what's my lowest number I can have? 3 halves. Do I get to include it?
Yes.
Sure do. How do I show that I include it? Bracket. And then it goes to infinity. So that's the domain. Perfect. Now let's talk about the range. Show me what a square root function looks like. Its parent. What does a square root function look like? Good. Good. There it is. All right. Now, was this vertically shifted anywhere? It didn't get shifted up and down. Yeah, I moved a little bit to the right, but who cares about that part? Well, it's the 3 halves to infinity. That's what we did. All right. But what's its range? What's my lowest y value? 0. It starts at 0. And then what's my highest y value? Infinity. So my domain of my original function is 3 halves to infinity. My range of my original function is 0 to infinity. Now, let's talk about this inverse. If this is true, what is the domain of my inverse? 0 to infinity. And then what would be my range of my inverse? 3 halves to infinity. Why is that true? Why is that true, guys? Because an inverse is a switch in x and y. Graphically, it would look like this. You guys totally did it perfect. I got my square root function just like that. Goes from 3 halves to infinity. Perfect. My range was 0 to infinity. What happened? Now my range is what? 3 halves to infinity, and my domain is 0 to infinity. Pretty cool? All right. You don't have to do 6, 18, or 19.